Welcome to this lesson. In this video, I'll be explaining how to interpret a position time graph and how to draw a velocity time graph from a position time graph and an acceleration time graph from a velocity time graph. Okay, so this is what you do. First thing that you need to do is to divide your graph into subsections. So we can see here we are given a position time graph. Okay, on our y-axis we have the position, and on the x-axis we are given the time in seconds. Okay, so what I'm gonna do is divide this graph into subsections so that I can analyze it part by part. So this is what I mean. You can see from 0 seconds to 2 seconds, right? Your position is 0 at the moment. Okay, then I'm gonna divide it from there, then I will divide it again from 2 seconds to 4 seconds, and I will analyze what is happening at that point. Okay, and then I can also divide it from 4 seconds to 6 seconds. So now I can start with the analyzing. I want you to remember the following. So in the previous videos I did say that if you are given a position time graph, and you are required to calculate your velocity or to find out your velocity, what you need to do is to calculate the gradient of the graph. Okay, you need to calculate the gradient of the position time graph in order to find your velocity. Okay, same thing if you're given the velocity time graph and you need to find out your acceleration, you simply need to calculate the gradient of the so the gradient of a velocity time graph gives you acceleration. But what if they gave you acceleration time graph and they want you to calculate the velocity? Now you're actually gonna do the opposite, which is to calculate the area. So instead of gradient, now you calculate area. So the area of an acceleration time graph gives you velocity, and the area of a velocity time graph will give you what? Position. Okay, so that is something that you need to know. So now let's look at this graph here. I'm just trying to draw a velocity time graph from this position time graph that I'm already given, and I've already divided it into subsections. Okay, so I'm just gonna put a drawing here. That is my drawing. So I have 0, then 1, 2, 3, 4, 5. So this is not up to scale. Okay, and then you have 1, 2, 3, 4, 5. Just gonna increase that. Okay, 6. So I want to draw my velocity time graph. So I'll have velocity here in meters per second. Then here I must have my time in seconds. Okay, so I'm going to go section by section and look at what's happening to my velocity. So from 0 seconds, so I said we must divide it into sections. So from 0 seconds, I'm going to write it down. From 0 to 2 seconds, my position, you can see it's a horizontal line which is at 0. So the position is at 0, which means the object is not moving. So if the object is not moving, it means the velocity is 0. So it means from 0 seconds to 2 seconds, I'm having a 0 velocity. The object is not moving. Okay, now I have to move to 2 seconds and 4 seconds. In between 2 and 4 seconds, let's look at what is happening. So we can see that the displacement is increasing with time at this point. So the object is actually moving, right? So let's look at the gradient of this line. It just moves like that and it starts getting more steep, which means the velocity is actually increasing, right? So the more steep the gradient, it means the velocity is increasing with time. So how do you represent an increasing motion? You know from mathematics, if you have a graph of y versus x, this is going to be increasing. So a straight line graph pointing in the positive direction shows an increase, right? So it means from 2 seconds to 4 seconds, you have an increasing velocity. So you must draw a straight line, but you need to find out where the straight line must be, okay, up to which point, okay, what is your velocity. So I'm just going to try and calculate from 2 seconds to first 4 seconds. I must first try calculate my velocity. So I'm given a position time graph. I want to find out the velocity. So I said to find the velocity from a position time graph, I must calculate what? The gradient of the position time graph. So I'm just going to calculate the gradient. So gradient, I have y2 minus y1 over x2 minus x1. This is something that we learned in mathematics. So now let's go to our graph and check our y2 and our y1, x1. And so here's my straight line, here's my line, and the graph is moving like that. So at this point on my y-axis, I have 4. So I can say here I'm having y2, which is 4. y1 starts from here, which is at 0. So here's my y1, right? Now let's look at our axis. On our x-axis, which is time, here's the first one, t1, which is 2. Here's the second one, t2, which is 4. So I can just come and substitute here. It means I have y2 minus y1, which is going to be 4 minus 0 over, okay, this is my y2, then it means my x2 is here, which is 4 minus 2, okay? So you can just put that in the calculator. 4 divided by 2 is going to be 2 meters. So that is your velocity. So it means now you know your velocity must increase up to what? 2 meters per second. So it's going to go from 0 up until 2 meters per second. So I'm just going to do that. So you must just use a ruler for that. So you must show that it's gonna be increasing with a straight line, okay? So from 2 to 4 seconds, your velocity is increasing. It increases up until 2 because you have calculated it, okay? That's if they want you to draw it up to scale. If they don't say that, you don't have to calculate, you just have to show how the shape will look like, okay? But it's best to know exactly where it must be in case they ask you what is the velocity, okay? Then let's move on from 4 seconds to 6 seconds. Let's look at what's happening here. From 4 seconds to 6 seconds, here our velocity is still increasing. Let's look at this, but the slope is not getting any steeper. The slope is the same, okay? What do I mean by this? The slope is the same because this is just a straight line. It's not curving or it's not getting any steeper. So it's just one straight line like that. It means now velocity is increasing constantly. It's not changing. If it was increasing by 2 units at 2 seconds, it's increasing again by 2 units at 4 seconds, again by 2 units at 6. So it's increasing constantly, okay? So how do I represent a constant motion? The gradient of a constant motion is going to be 0. So a gradient of 0 is represented by a horizontal line. So it means from 4 seconds up until 6 seconds, I'm going to have a horizontal line which shows uniform motion, okay? So it's increasing constantly. So there is my gradient. This shows a 0 gradient. So if motion increases constantly, your gradient is going to be 0, because the same value you had at 6 seconds is the same value that you're having now at 8 seconds. The same value you had at 4 seconds is the same value you're having at 5 seconds. So that is why the graph looks like this. Okay, you will just have to get used at this kind of like getting these kind of shapes. Okay, the more you do more of the drawings, the more you'll get used to it. So this is the velocity time graph. Okay, from here, when you have to draw the acceleration time graph, you just use the same logic. The acceleration time graph, now we will get it from the velocity time graph. Okay, so quickly I'm just gonna put this here. I must just try get my acceleration time graph from this. So I have 0 seconds, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So here I have acceleration in meters per second squared. Then here I have time in seconds. Okay, let's check. Again, we must divide the graph into subsections from 0 to 2 seconds. Okay, so from 0 to 2 seconds, what is happening to that graph? Velocity is 0. And in order to find acceleration, we must just calculate the gradient. So if velocity is 0, it means acceleration is also 0. So at this point, acceleration is also 0. It's 0. Then from 2 seconds to 4 seconds, our acceleration is increasing. It's a straight line. But is the slope changing? No. Now we are having constant acceleration. I just explained to you what it means when something is changing constantly. It means you're gonna have a horizontal line because your gradient must be 0. Okay, so where must be the horizontal line be? You must just calculate your acceleration at that point. Okay, so we already said from 0 seconds to 2 seconds, since velocity is 0, acceleration is also 0. Then from 2 seconds to 4 seconds, now let's calculate the gradient. So acceleration, same thing that you did for velocity, you're gonna calculate the gradient. Y2 here, it's gonna be 2. Y1 is at 0. X2, so since this is Y2, your Y2 will be here at 4. So you have 4 minus X2, which is at 0. 0. So you have 2 over 4, which is 0.5 or a half. Okay, so there is a half. So from 2 to 4 seconds, you are having a horizontal line. Okay, then let's see what's going to happen at 4 seconds to 0 to 6 seconds. So from 4 seconds to 6 seconds, we must calculate the gradient in order to find acceleration. So our y2 here, which is here, right? So this is our first point, y1, then our y2 will be here. First point, x1 or x2 will be here. So our y2, what is the value? It's 2. Minus y1, what is the value? It's also 2. So that is gonna be 0. So 0 divided by any number is gonna be 0. So at this point, acceleration is going to be 0 because our slope is constant. The gradient is 0. So if the gradient is 0, acceleration is going to be 0. So it means our line will be from 4 to 6. It's going to be at 0. So that is how we can draw an acceleration time graph from a velocity time graph. Okay, you just need to get used to this kind of shapes, how it will look like, and all those kind of things. Okay, so that's all I wanted to show you. Sometimes they don't ask you to draw, they can just ask you to calculate what is the acceleration from this point to this point, what is the velocity from this point to this point. You will just need to know, if I'm given this graph, this is how I get the acceleration. If I'm given this graph, this is how I get the velocity. Okay, so this is going to help you find that out. Okay.